Okay, the first topic we will cover is basics of data analytics, right? Everyone has their notebook on, right? Okay, so the most important question is, what is data, right? For you to be able to train your machine learning algorithms to do data science, to do data analytics, you need data. But then what is data, right? So it can be simply defined as a collection of facts, right? By me standing here and counting people who are using Windows or Mac, that's collection of data, right? Those are facts. You can't change that because it's what I'm seeing, right? I'm collecting data, right? So basically, that is what is data. So what is data analytics? Does anyone have a clue without even looking at the screen? Mm-hmm. Yeah, you're correct. So data analytics is collection of data because you can't do any analyzation if you do not have data. You have to collect the data, you have to transform it. So by transforming means data preparation, right? You have to clean the data because remember, garbage in, garbage out. So you whatever algorithm or insights are based will reflect how good your data is. So if you have crappy data, that means also your algorithm won't work as expected, right? So you need to clean your data, you need to transform your data, the stuff, right? And then organization of data, it's when you visualize the data because you need to tell the story about your data once you're done analyzing, right? So the definition which we have here is data analytics is the collection, transformation, and organization of data in order to draw conclusion, make prediction, and drive informed decision making. So we eliminate guessworking, right? So instead of us saying, no, I think it's because of this, we do not do that. We have to look at the facts, right? Remember, data are the facts, right? And then, so let's clear out the misconceptions, right? So the difference between data science and data analytics is that in data science, they use data to ask questions, right? So instead of in data analytics, we have questions first. So I might want to find out why people are coming late to the master classes. So I'm going to run a survey, right? So firstly, I had a question why people were running late. And then now I'm going to ask the questions, right? I'm going to give it to the audience, the survey, to answer why people are running late, right? So firstly, you ask the question and then collect the data. That's data analytics. But then data science, you have the data and then you transform it, you analyze it, you draw questions from that, right? As you can see from the definition, data science can be described as creating new ways of modeling and understanding the unknown by using raw data. That means we have the data and then we have to find insights. We do not ask any questions before, right? And in data analytics, it means that in data science, they create new questions from the data, while in data analytics, we find answers from that data, right? So if I'm going fast, just shout, right? Where is it applied? Just so can someone tell me the applications of data analytics? On Google Drive. Google Drive. Okay. Are you guys able to access the notebooks, the resources from the Google Drive? Please respond in the chat. We made it accessible to everyone. Okay, yeah, you can. Yeah, where is it applied?
ask questions, but then inform a product based on the answers that we get from that. I don't know if anybody else would say data, but I work in banking and data analytics.
Okay.
Oh, yes.
So that means please repeat that again so that everyone can hear you.
Okay, so let me just try and get into it.
Okay, cool. Anyone else? So are you also in the meeting?
Hello, good. Can you hear me?
The sound.
Hello?
Yeah, we can hear you. Hi.
Yeah, can you hear me?
Yeah, I can hear you.
Oh, fantastic. Actually, I just need to have some sort of clarification on this topic that we're covering today. What risk is there really in terms of this being fully automated, if at all?
What's being fully automated? Data analytics.
Yeah.
So remember, you have to ask questions, right? So I don't understand when you're saying fully automated, because now in data analytics, firstly, you have questions, right? Or you have an objective, right? You want to achieve something. So you need to ask questions and then after collect the data and transform it. By that, I mean data cleaning, data analysis, visualization, and then after you have to draw insights. So it's different from machine learning, because now in machine learning, you'll be using the computer so that it can make all sorts of conclusions. So it may be a prediction algorithm, it may be clustering, right? So we know there's something called K-clustering. Maybe we just want to create tailor-made customization product for customers, right? So in order for us to market to each and every customer differently, so we don't want to, let's say, sell the same thing to everyone. Some might be allergic to that product and also they might not be buying it at all. So our marketing budget goes to waste. So in order for us to be able to create a different product for people so that they can use that, we have to be able to analyze that from the data, and that's where machine learning comes in. So it will just automatically do that for you. And in data analytics, we are the ones, the humans, that are the ones who are analyzing the whole thing.
Okay, fantastic. Let me just, before you lose me, let me just get this straight. Machine learning and AI, the difference there, what really is it?
Okay, machine learning and AI. So machine learning is a subset of AI, right? AI covers everything based on automation, and machine learning is basically teaching computers how to learn as people do, right? So machine learning covers the part of AI that has to do with learning, teaching robots how to speak, using NLP, the likes of that. So machine learning and AI are not different, because AI covers everything, and then machine learning is just a subset which is responsible for how the AI learns. I sorted.
Yeah, I am. But I just want to have clarification that you are saying that this field is still going to be relevant for the next coming future.
Oh yeah, remember, so when retail, banking, and also healthcare want to design custom-made products for people, and also let's say you're trying to find out why people are churning out of your business, right? So churning out meaning that people leave it. So let's say you see when you go to Standard Bank, they will offer you a SIM card which has airtime and also data. Maybe you might be leaving telecom because of its network. So we use data analytics to analyze that, why people are leaving our network. So we can just go and ask a questionnaire, survey, or just by analyzing where let's say you take the time series, right? So let's say people stay with your company for 9 months, and then after that they leave. So those are the kind of questions which you need to ask and also investigate, right? So it will still be irrelevant, right? Regardless of us using machine learning to do all sorts of things, there are some things which computers
Need
can't
human
catch, which will still
intelligence.
be able to analyze for ourselves.
Okay. No,
Cool.
fantastic. I'm happy with that. Thank you very
Okay,
much,
cool.
sir.
Oh, yeah. So they were asking the difference between AI and machine learning, right? So there is no difference. AI just, so machine learning is a subset of AI. Machine learning is responsible for how AI learn, right? Self-explanatory machine learning, right? So how we teach robots, we use machine learning, right? AI covers all of that. So that's what they were asking. And also if data analytics will still be relevant in the next coming decade. So regardless of us using machine learning to analyze everything, we can't fully automate it as of now because there are some things which the computers can't do, which humans still strive in, right? So it will still be relevant, except if we achieve AGI anytime soon, which I doubt. Okay, cool. Can we carry on? Kuku, you have to repeat where is it applied.
Okay, so what I had said earlier is that I work in banking. So in terms of where data analytics is applied is in banking, we can't keep releasing products. And then after testing that product, then we have to bring it back and roll it back to say it's not working. And that's why we are a questions first and product after. So we formulate a product after we've asked the necessary questions. So we analyze our demographics first and then go back into forming a product that's suitable. And how you analyze a demographic is exactly that. You've got surveys coming in, you've got on the ground surveying as well as off the ground surveying. So this is where we use things like your social media to ask you to vote on a poll or to ask a silly question, but essentially we're looking for data. And when we get that data, we then go and analyze it. So that's where data analytics is used in banking. I'm not too sure where anyone else would come in to say retail. My mom works in retail, but I have not quite understood completely as to how they use it in retail. I can only speak for banking.
You have something to say? Thanks, Kuku. Hey, you can talk.
I'm just adding on to the retail part. So what I've seen in retail is that now retailers want to understand what exactly what their consumers' purchasing behavior actually is. So what they've done, they've created the smart shopper cards and all that. So they collect all of the data, all your transactions and all that, and then they can put a profile on you as a customer of what exactly do you buy on a monthly basis. That allows them to actually tailor their marketing towards you in order for them to actually get more sales or something like that.
Perfect. So in retail, they use data analytics to understand their customers more and also their buying habits. As you said that you have your smart shopper card, right? So when they want to market, so now it's simple to market because they know exactly what are you buying, right? As you can see, they create sales. They'll just send you messages, right? So that we have the spatial, not everyone will be receiving the same text as you, right? So if you're used to buying, let's say, chicken, they'll be marketing chicken to you, right? So let's say someone else doesn't eat that. So they can't do that. If you do that, you'll be making people angry. You might as well lose business. Imagine selling something which I'm allergic to. If they send me a text to something I'm allergic to, I'll feel offended because why? That's why so data analytics is important. You are able to customize and also target each and every customer individually instead of saying no. The smart, we're trying to sell everyone pork, right? So just say we have a special pork. Some people are allergic to that. You don't want to do that, right? So in healthcare also, they use data analytics to analyze patients' details. right? So let's say you take medication. So they want to find out how many people are taking this medication. So when they want to go stock, right? So you need to stock those meds. You can't just go, okay, say, we want to, with COVID, right? The last time I went to Dragon City, they were selling masks. So they had boxes of masks. And now COVID is no longer there. So it makes no sense why you do that. So if you go to the World Health Organization and pull the data on the stats of COVID, you can predict if COVID will come back or not. And if you can see that, hey, there's an uptrend. So now you know that, okay, we might also face lockdown and start wearing masks again. So you can buy those and make money out of it. But then now buying those just by using guesswork, saying no, COVID might come back. It's a poor business decision, right? So that's why, as you can see, where ways to use data analytics improve decision making, we eliminate guessworking, right? We don't want to do any guessworking in terms of our when making decisions, and also improve customer service, as he said, using smart shopper cards, right? And also effective marketing. So when I know that this person buys this every month, it's easy for me to market to them because now I understand their needs, right? I can just create sales based on that and only advertise to that person. As you can see with Facebook, right? So each and every one of us, when they're using social media, you won't get the same ads. Everyone has their own tailor-made ads, right? They customize them. Okay, so we have three types of data analytics, starting from the basic one to the most complex. So the basic one is descriptive analytics, right? Hindsight, what happened? So we're trying to find out let's say what made the sales peak, right? So in the past, we don't understand what's happening. We have all this data, but then raw data doesn't tell us anything. We have to transform it and then also tell a story so that we know what happened in the past, right? For those who are trading, you have to use previous market structures to find out, okay, cool, what happened so that the market will have an uptrend, or what happened so that the market will have a downtrend, right? And secondly, we have predictive analysis, what will happen. So let's say you're trying to find out in the future, you collect all the data. Let's say this we collected the data from the first masterclass until today. So we want to find out how many people will be coming on the next class, right? So we'll be using that to predict the number of people that will be present. Boom. And then there's a new one, which is prescriptive analytics, which is, as Google said, they use it in order to form new products, right? How can we make it happen? So let's say Google wants to push an app. They will just come and ask questions. What do you guys need? And also, how can we make that happen, right? So this is the most complex one. So every time you want to use data analytics in your daily life, you can just start with descriptive. If that doesn't work, you use prescriptive. And then lastly, it's prescriptive analytics, right? Are we all cool with that? Okay, so the data analytics workflow. Oh yeah, you can just unmute.
Yeah, hi everyone. So what we use data analytics from in the mining perspective, we basically, let's say for example, you're extracting your different types of ores. You'd see usually, let's say for example, give you a specific example of a bulk commodity, you mining tonnages of manganese. So when you're mining tonnages of manganese, you're basically make your biggest profit based on your specs of the type of material that you're extracting, not on the tonnages that you produce. So when you look at the trend of the data, we're extracting specifically, looking at the specific trends, which target material to target to get the best type of specs of manganese that's going to be used for steel. It's the same thing that's also used in coal. So there's a system that they call penalty and reward system. So if you're producing terrible coal of material, you get penalized. But if you're producing good types of coal, because for example, they're looking at anthracite, you produce good anthracite, you get rewards for that. So if you using data analytics, you then identify which type of units or seam material to target specifically. You'll be following a trend and identifying where in the best structures you've been mining or extracting the best types of material. So data analytics helps in that particular regard in mining. Yes.
Okay, thank you, Musa. That's well said. So data analytics is used in every sector, right? I do not have knowledge of every sector, but then every sector has data analytics now, right? As you saw, we use it in banking, we use it in mining, we use it in retail, we use it everywhere, right? There's some application of data analytics, right? Okay, cool. The workflow of data analytics, right? So firstly, we need to understand the problem. You need to define what the problem is, right? It's not like your data science where they give you raw data and you have to draw questions from that. What happened? So in data analytics, we're trying to find out, we define the problem. So let's say you work as an HR. So it doesn't have to be in engineering or computer science. So in HR, right? You work in HR and you're trying to find out how we can make the work environment friendly, right? For interns. So you'll be asking people who moved from being interns to working at that place full time, right? So you're collecting the data. So now the question is, how can we make the working environment friendly to interns, right? So you already know the question and it's not ambiguous, right? There's no confusion in that. You know exactly what to ask. And also now you are able to ask effective questions and relevant ones, right? So you can ask how were the people treating you? What made you stay with us? Those type of questions so that you are able to make the working environment friendly for each and every intern that will come into your company next time, right? So the second step is prepare and process the data, right? You can't use the data as raw as it is. You need to clean the data. Let's say you have duplicates in your data. When you use that in code, you won't be able to run your code. It will give you errors. So you will see when we're doing our data analysis on the second part of this, we'll be cleaning the null values. Null values means that there are no values, right? So that data is messed up. And also you need to remove outliers. So let's say we have two people, everyone here agrees on something, right? Everyone's saying this, and then we have only two people who are saying no. So those are outliers because we can't have 95% of the people within the same range, and then we have another one outside. So that will mess with our data, and then now we will not be able to predict exactly, and our algorithms, or let's say our insight, will just lead us astray because of that one outlier or two outliers, right? And then also transformation of data. So I won't be covering machine learning, but then when you're doing machine learning, you have to transform your data. Let's say you have names. You can't use names. Computers do not understand strings, right? They can only store strings, but then now when you're training them, they can't understand that. So most algorithms need your data to be in terms of numbers. They have to be numerical values. It can be your booleans, it can be your floats, it can be your integers, but then not objects. So if you're going to use strings, then you won't be getting the necessary answers. And then in data analytics, we also need to analyze the data. You have to apply business intelligence tools, right? So you need to analyze your data. So that means you have to check if there's a trend. We have what we call trends. So it can be an uptrend, it can be a downtrend, and we have what we call seasonality. Let's say people buy winter clothes in spring. Why? Google.
So the seasonality one, I'd actually like to tackle that one with you. As I mentioned earlier, so my mom works in retail, right? And they do what they call a post-season. So they always look at what people bought in the last season and what's been interesting in the previous, say, 3 to 4 years. You're finding a lot of people doing the opposite. So you'll notice if you are buying winter clothes in summer, they're a lot cheaper. And if you're buying summer clothes in winter, they are also a lot cheaper. So what you do is you're constantly wearing a previous trend. So if you look at my summer clothes most of the time, you'll find that what you guys were wearing last year is what I'm wearing this year, because I bought it when summer was ending and we were heading into winter. So understanding seasonality also comes into your buying power. When it comes to retail, you're looking at your consumer, and not every consumer every season goes to buy clothes. Some consumers, especially myself, and this is me giving away information that maybe the retailers will hate me for, I always wait for Woolies 65% off before I go buy anything. Like, you'll find the coat they released last year, I'm only wearing next year. The following winter is when I'm going to wear it, because when I get it 65% off, I'm getting it probably at their cost, as opposed to me buying it for them to make profit. So that's where seasonality comes in, and that's where trends come in. And that's the relationship between trends and seasonality. Yeah. It's when you've looked at a trend and you're like, oh, this is nice. And that's why also I wear mostly classic clothes as opposed to trend clothes. I will go and buy a trench coat as opposed to buying a specific color. I'll go for a classic tan trench coat. It never goes out of style. It's always in so the trend of it is the trend never quite ends, but seasonally I'm only going to be wearing it in winter. Just my 2 cents on that for the retailers.
Okay, thanks, Kuku. So you can see we do not use data analytics in corporate only. You can also apply it to your everyday life, right? So let's say you're trying to find the perfect schedule for you to read, right? So most people I know, they study at night. So you'll be having, you collect data. Let's say for this week, you'll be collecting data. Okay, today I'm just going to read during the day, tomorrow maybe at night, so that you can find the optimal, right? So the best time for you to study, right? So most people want to read at night. Maybe they analyze that they were collecting the data all the time, but then you do not write that on spreadsheet. Obviously, you know that, okay, this week I was trying to read at night and it worked. I was able to retain most of the information I was reading about. Or let's say you go to the gym, right? So you just check, if I go to the gym in the morning, will I be able to have energy during the day, right? So that's collection of data, right? And then the analysis will be you trying to figure out if you are able to go through the day if you go to the gym in the morning, or else you can just go to the gym when you come back from work or from school, right? Okay, so interpreting and sharing your findings. Sharing your findings, telling a story, right? You have to visualize your data, right? Now it comes to you creating dashboards and also graphs so that you can see the trends. We'll show you that when we go to the coding part. Okay, so next, it's the skills which you need to be a data analyst. So as you can see, we have SQL. Someone talking on the chat. And then we have business intelligence tools. We have Python and R, which are programming languages. SQL is basically how you store your data and be able to query it, right? So when you want to retrieve your data, when you want to filter it, you'll be using SQL. And then you have statistic, right? So statistic plays a huge role in you finding trends, seasonality. And then writing and communication, how you tell the story using the data. Remember, you're a data analyst, right? You're working for a certain business. So you need to be able to come and tell your bosses, okay, this is what I found out, because now you can't give them a bunch of numbers and also graphs without even telling. You have to tell a story. Okay, this is what I found out, and this is how we can tackle it, right? And also critical thinking and problem solving. You need to be analytical, as it says, data analyst, right? So we can just go and check the definitions here, right? SQL, so SQL or SQL, it's your preference how you want to pronounce it. So they use it to store, process, and analyze data, and also manipulate structured data to create data models. So this is where you store your data, right? So you create tables, to store your data. When they're referring to database, they're referring to SQL. Boom. And then we have Microsoft Excel. So you'll be able to tell a story using Microsoft Excel, as you have saw that we'll be covering pivot tables and also dashboards. I'll be showing you how to create reports, perform calculations, and also analyze data. So Excel has functions which automate this for you and just ticks. You don't have to write any line of code, right? And then stats, you need to be able to understand linear algebra, statistics, and probability in order for you to deal with high dimensional data. So now we have what we call big data, right? So it'll be thousands or millions amounts of data. Imagine if you're working at Google having to deal with all that data. So it's probably millions per day or billions, I'm not sure. So you need to be able to have skills and stats so that you are able to calculate everything and also get meaningful insights from it. And then programming languages, we have R or Python. So it depends which one are you comfortable with. So they're used for focusing trends and also automating tasks. You can't use your calculator to process big data, right? Imagine dealing with 1,000 people. So it will take you the whole day. But then when you're using Python or R, in combination with Excel, you can just do that in minutes, right? And also writing and lastly, writing and communication. So it is very important that the insight you present 100% clear and unambiguous. So you need to tell a story, right? So the insights which you have needs to be unambiguous. They have to tell the clear story. People shouldn't be guessing. Remember, we use data analytics to improve decision making so that we eliminate guessworking. So that's why you have to have strong writing and communication skills. Cool. Okay, Python packages. You guys recognize some of this? Where do you guys use this? Have you unmuted?
Okay, so personally, Numpy and Pandas, I use those a lot. Numpy for school, but Pandas a lot for my graph work. I do take statistics as a module this year and next year, so those two, they are my place to be. Matplotlib, I know it as well, but it hasn't been something that I've had to use a lot. But yeah, next year is going to be that year for me, Matplotlib year.
Okay, thanks, Google. Anyone else? Okay, I'll come back to you, Musa.
It's actually a question. So for my degree, basically, we study SQL a lot, and we also use Microsoft Access and all that. So I was just wondering now, since, okay, back in the days, like the databases that we use are the relational databases, which SQL mostly works in.
Yeah, it's
and now seeing that there are new databases that have been created, like the NoSQL databases, and seeing that companies such as Google, the big companies are actually using those because they are more effective in actually managing big data and all that.
Yeah.
So I was wondering, how much space is there for people who still specialize in relational databases as opposed to people who actually have skills in also the NoSQL databases?
Okay, Google can answer that. I'm going to take that question. And the reason I'm going to take it is I too have a lot of databases within within school, but also within work. And I would say to you, you're safe either way, but start transforming. Always look at a career as to where it's going and then start to try and get there first. If you've worked, for instance, I've been in banking for almost 4 years and I'm about to leave banking for telecommunications. And I have found that sooner or later, telecommunications is going to be huge in banking. People are into personalization. So a person wants to be dealing with a specific product for them and specific assistance for themselves. So I've been in banking and in support for about 4 years. You are best suited moving forward. I'm not to say you shouldn't be in the relational databases, but I would say always churn your skills. And this is career advice for anyone. always try and put together skills that are not always found together. You can be super great in coding, but you want to tie that to a skill that's not always found with coding. And that's why when you go and you understand business so well, and yet you've got computer science, I'm not studying computer science and studying informatics because I still get the best of both worlds. I code every day for school, but also I'm understanding how businesses and accountancy works. So those are skills that are not always found together, and you want to find those skills together. It makes you what we would call in the workplace a unicorn. You're not easily found. You come in and you change the work, because what Surashka and Njabulo and Musa would be doing, Ukuku does all of that and actually understands the relationships between those three jobs.
Okay, I answered. Yeah, so your task for today is just go collect data on the trend, so you can collect data on SQL and also NoSQL, right? Relational versus non-relational databases. And yeah, check the trend. Just use predictive analytics, right? Yeah, just apply something which you have learned today, right? Musa, you had something to say.
Yeah. So I pretty much use most of the packages there, except for IPython. I also use Seaborn for high quality visualization, moving from Matplotlib. So basically, I use most of them. Scikit-learn for my data processing and machine learning, stuff like that. So yeah, pretty much.
Okay, so Numpy is used mostly for numerical computation, right? So you have your function, you can process n-dimensional data using Numpy. So it's good with arrays. It's written in C, C++, and also I think Java. I might be wrong, but then C and C++, right? So it's super fast. So you are able to make calculations. It has your Fourier transforms. You have your linear algebra functions. So Numpy, when you want to do any mathematical calculations, it's your go-to package, right? And then we have SciPy, which is used for scientific computing and also engineering modules, right? So here, when you want to do, as Musa has said, when you want to do your scientific and engineering computing, this has most of the packages and also the functions which will allow you to do that. Matplotlib is just for plotting, right? So when you want to visualize your your data, you use Matplotlib. It has your bar graphs, it has your scatter plot, everything you want to use in terms of visualization is on Matplotlib. And then pandas is for manipulating data, storing data. So when you want to play around with your data, you use pandas, right? So you load it into your data frame. I'll show you that when we go to the coding part, right? You use pandas. And scikit-learn, it has your machine learning functions, right? So when you want to do machine learning, you just use scikit-learn, right? It's super good for people who are just beginners in machine learning. Instead of using TensorFlows and the other deep stuff, right? You can just use scikit-learn. So we also have defined them here. So you can see Numpy for numerical computation, mostly used to do computation on n-dimensional arrays, as I've said, and SciPy for scientific computation, mostly used for scientific and engineering modules, and then pandas for data manipulation and analysis. So you can use pandas to get your stats and also manipulate the data. So if you want to delete maybe the whole column from Microsoft Excel and you can't use Excel, you can just load it to pandas, delete it. You can automate stuff using that. Matplotlib is for visualization and also plotting. And then scikit-learn contains tool for machine learning and also data mining, as Musa said, data processing as well. So now we'll go to the practical part, right? So we'll just do pivot tables and also dashboard using Microsoft Excel, right? Does anyone know what are pivot tables and also dashboards? Okay, cool. So a pivot table is used to create reports from data in form of tables, right? So we'll just have our data and create a table from it, and then use Excel to create tables and also dashboard from that. right? It allows us to quickly summarize and analyze data in our spreadsheet. So as I've said, you do not have to write any line of code with Excel. You can just, it's drag and drop, right? And then we have components